All right, I thought I would, since I'm making the key anyways, just work through this with you. If you're interested, not, it's all good. So here, Samuel would like to purchase an ATV worth $3,000. So it's kind of like Samuel would like to have $3,000 to buy this, right? How much would he need to deposit if the bank offers a 48-month GIC with an interest rate of 3.25%? Okay. So we're kind of in a position, right? First of all, you should notice that there are no compounding periods here. So I will immediately set this up, right? And you might be tempted to put the 3,000 in here, but no, that's what you want. That's basically A, right? This is A in this scenario. How much would you need to deposit? So that's the question mark. There's a 48-month GIC, which is the 4-year, right? You go 4 divided by 12, that's 4 years, right? And then the rate is 3.25%, which is 0.0325. And two unknowns here, right? So I will use this formula here. A is equal to P times 1 plus RT. I know the 3,000 goes in there. The initial amount, I don't know. 1 plus the rate, all of that times time. And I turn that into a square bracket there. So you get, out of this, you get 3,000 is equal to P times 1.13, right? This whole thing reduces to this. I divide both sides by 1.13. And when you get this side, you get 2654.87. Okay. So this is the initial amount that he would need to deposit so that in 4 years he would have enough money to buy that, right? Or basically have 3,000 just in the account. What is the rate of return of this investment? Why is this rate different than the interest rate? So let's just figure out the rate of return first. And so you get 345.13. I'm fast forwarding here, so I should maybe not do that. But we go future value minus initial, right, divided by the initial, times 100. When you subtract the top, you get 345.13 divided by 2654.87 times 100, right? And that ends up being 12.999 and so forth. That is the roughly 13%, right? And I'm just going to double check that so that I actually, yeah, that looks right to me. I'm just going to go double check, yeah, divided by 2654.87 times 100. Yeah, so that's 13% there. We're all good. And what's the difference between this rate and the interest rate? Well, rate of return, it compares the initial amount or the future value to the initial amount. Okay, to the initial principal. So it's how much, right? It tells us the growth since inception. How's that for a word, eh? Since inception, since you started that investment. Whereas the interest rate, right, right, gives us the growth per year. of the investment. So that's how they're different. Interest rate is a yearly amount, yearly rate, and so it goes up by that rate. Okay. Okay, next page. This would be page 12. Okay, at the end of the 48 months, I guess I should say, Samuel does not buy the TV, instead takes his 3,000, reinvested, smart move. All right, let's keep going. So the takes the 3,000, reinvested into a 5-year GIC at a rate of 5.12%, greater rate because you're locking in it for a longer time. How much money would you have at the end of the 5 years? So I will go ahead and do, and some of you probably like, I don't need to do this inventory. I know already where this is going, but you know, it doesn't hurt to do this. So the time is already in years, perfect. The interest rate, let's turn it from a percent to a decimal. Principal is the 3,000, right? In this case, it turns into principal. So technically, that is what it's asking. Oh, well, okay, hold it. How much money would you have at the end? So I could find the interest and then just add it to the 3,000, right? And then I would effectively have found the whole amount, right? The final amount or the future value. So you can choose to just use I. So how about I do that? I is equal to 3,000 times 0.512 times 5. And see what we get there. Okay. 3,000 times 5 times 0.05112. That's $768 exactly that was earned, right? So the final amount would be 3,000 plus 768, which would be $3,768. Okay. Alternatively, what you could have done is just jumped right in here, no problem, right? So you could have just gone 3,000 and then 1 plus rate times 5, right? And then have that scenario. You should get, right, the same. You should get the same, right? So this is 1.256. So 3,000 times that is exactly same. Okay, so there are some options on how to do things from time to time. So just as long as you show me the work, it should all jive, right? Keep on saying that. What's the rate of return over the 9 years of the initial investment deposit, right? So remember, we're going back 9 years. So this took us 5, and then we had it in for 4 years at the beginning, right? So what is the rate of return after 9 years? So you have to be careful here. Initially, at the very beginning, we invested. Let me see here. Sorry. We invested this much, 2654.87. Okay. So we will say, well, we have right now at the end of all the 9 years, the future value was that. Then we're going to subtract the amount, right? The amount that we wanted. Let me just see here. 2654.87. I just wanted to make sure I get that right. Okay, and then we divide it by 2654.87. So this rate of return goes back right to the beginning. And we go times 100. So we get, this is good to write down. So we go that divided by 2654.87 times 100. So that's 41.93%. That is the rate of return since the very beginning. And you might be like, well, right? You can totally tell that it's very different than the interest rate, right? That's the yearly growth year after year. This is telling you from the beginning, right? How much has it gained? And so you basically um, figure it out this way. Okay. Grant purchases 25,000 worth of savings bonds, which pays a simple interest rate. It's actually telling you that it's simple interest rate, so that's a dead giveaway that it's going to be simple interest rate. If the future value is this much after 5 years, what was the interest rate? I will show you here an alternative way. Remember I told you when there's two unknowns, you just use that A is equal to P formula. Let me show you here what I'm going to do. So the grant, you purchase this much of savings bonds. That's what you call it. You purchase it, but it's like an investment. And the time is 5 years. And this is what they're asking for. What's the interest rate, right? What is the rate? And this apparently is unknown to us. However, if you're given the final and the initial, you can actually find out the interest that was earned in this particular case. So I'm actually going to go 29,375 minus 25,000. That's actually 4,375. So that's actually, in a sense, given to you, but not explicitly, right? It's just in the background. And this goes back to the fact that A is P plus I, right? Therefore, from this, you can also say that, well, I is going to be A minus P, right? And if you think about it, this is what we do when we find our rate of return, and we do call that interest, right? So just doing some algebra, we can also determine this. So that's what I used here. So technically, I can just use this formula. I equals P RT. I have initial investment. I don't know what the rate is, and the time is 5, right? So I multiply these two, so you get 4375, and then it's 5 times 25,000. That's 125,000 R. No decimal, so nice. Divided like that, and rate is 4375 divided by, that's 0.035. So that's fine, but R is also 3.5% if you turn it into a percentage, right? So both of them are acceptable. Just see what it asks you for. All right. B, if he finds his dream home after 4.5 years, how much would he have in his account at the time for a down payment if the interest was paid? So this is a bit of a different story here. If we do IPRT, time is 4.5 years. It's okay to have it as a decimal. The rate is going to be the same. Interest rate is not, we're not told that it changes. So we'll say 3.5%, just 0.035. P is the principal. That's the 25,000 that we started off with. And so basically, in this case, there's only one unknown here. So obviously it would be a good idea to figure that out. Okay. So we go P R T, and then you go for it. So that's 393750. That's the interest, so don't fall for it, right? It's important, but how much would he have in his account? How much would he have in his account? They're really asking for this, right? So A is equal to 25,000 plus 3937.50, right? So that's really what you want. So that is 28,937.50. Interest earned, right? This is the interest earned. This is in the account, right? In the account after 4.5 years. All right, so there you have it. Moving on. I'm going to do this in class, so we'll just wait for that. Simple interest review. This should be quite easy to fill in. So complete the table below using the formula I equals PRT and the fact that the final amount is principal plus interest. Remember that time must always be expressed in years and that the interest rate must be expressed as a decimal. Which is the best investment and why? So we're gonna fill in this chart. Maybe I will pause it after a while and just give you the final. I did give you some work, a work area down here, so maybe I might use. So if you have a principal of this, interest of that, and this is how much you earned, what's the time? Okay, so I will use for A, I will use this formula. And actually, we could already fill in the future value, right? Because future value is principal plus interest. So this is 5,145. Okay, we'll put that in there. But I need to figure out the time it takes. So the interest is 145. Principal is 5,000. The rate is, let's turn this into a 1.75%, which is 0.0175. Don't round it, okay? And we need to figure out time. So we'll multiply these two, 5,000 times 0.0175. And so that is 8750 or 87.5 T, and this is 145. So all you need to do is divide both sides by 8750. 87.5, sorry. Cancel that out. And that is 1.666 years. Remember, you need to feed it years, this formula, so it will give it back. It will give back a time in years. So this is 1.66 years. And rate of return, we'll just go interest, right? 145 divided by 5,000. And because it's a chart, I might skip that next time. But it's 145 divided by 5,000 times 100. So that's 2.9% rate of return. Okay. Over here, we're asked to figure out the principal. We will make sure this is 300 out of 365. This is 2.25, so it's 2.25%. So I do the conversions right away. So for B, using this formula, I have I, which is 400 bucks. Right, I couldn't find the future value just yet because I need these two. So I will figure that out. So I, which is 400 bucks, is equal to principal, which is unknown. The rate is 0.025. And the time is 400 over 365. Okay, so it's over a year. So what do you do here? I would multiply this out first and clean it up a bit. So 0.025 times 400 divided by 365. That's 0.027, and that keeps going P. And so I will just divide both sides by that. It cancels out, so it's 400 divided by this, which is on my calculator. So that actually turns out to be, look at my calculator, 14,599,999. So right, so that actually will round to 14,600. 14,600 exactly. And so that is my initial amount. Investment. Be comfortable with the different terminologies. So the future value is just adding this up, right? So that'd be 15,000. And then the rate of return, I'm just going to go 400 divided by, right? I take the interest divided by 14,600 and then multiply it by 100. And that one is 2.74%. Okay. I hope you get the idea. C. You have PRT. All you need to figure out is the interest. So this is actually the easiest scenario, right? So 1200, let's convert this out of 12. This is 0.05. So we just plug it in and go. Okay, so there's no division, no isolating necessary here. Times 8 divided by 12. So that's actually 40 bucks. So I'll put that in there. So in total, it's 1240. Right, if you add these two, and then it's 40, right? The interest you earned, which would be final minus the initial, that's 40 over the initial times 100. That's 3.33%. So even though you didn't earn a whole lot, compared to the initial value, it's actually doing pretty good, right? 4,700. So what is missing is rate. So we have everything else. So maybe I'll just do D right here. Sorry, D. I is equal to PRT. I know I know principal. I don't know R. And time is 3, and it's already in years. So I multiply these two, 4,700 times 3. So that's 300 is equal to 1,400 R. 14,100. 14,100 cancel. So 300 divided by 14,100 is 0.0213. If you multiply that by 100, you can also say that rate is 2.13%. Okay. But just got to be careful what is being asked, right? So we can put that in as a percentage. Why not? The future values, just adding those up, that's 5 grand. And this would be 300 divided by 4,700 times 100. That's 6.38%. And looking at the rate of return, this one down here seems to have done the best, even though it had the one of the lowest interest rates. This one, the first investment, was a bit lower. But anyways, the rate of return tells you how much it has grown compared to the beginning. Okay, sometimes it's time dependent, sometimes it isn't. Okay? Especially when it's in a mutual fund where it goes up and down. Uh, having it for a long time, if it happens to be down the market, then it will look like you didn't really have any gain, right? So, which investment is better? Investment D is best since it offers the greatest rate of return. Keep going. I might have to cut this short because my next class is starting soon. So a bank is offering simple interest at this for a 5-year GIC. What principal would you need to invest if you have 20,000 at the end of the term? If you have this at the end of the term, this is not the initial, this is the final value, final amount. So we do a little IPRT. This is 3.2, which is percent, which is 0.032. Time is 5 years. What principal is question mark, and this is also question mark, right? So this is definitely a scenario where you have to use the other formula, this one. So A is 20,000. P is unknown. 1 plus rate times 5. And so I'll figure out what that is inside the brackets. $1.16. So that's 1.16p. Divide both sides by 116. P is 17,241.38. So that's how much would have had to be invested at the beginning. Okay. How long would it take for the GIC to be worth 25,000? So that's interesting. How long would it take for it to get to this point? I will use this one right away. And so this one is here. You want it to be 25,000. The principal, obviously, right? That initial amount is the same. That's what it was invested. You figured it out. So that comes in here. 1 plus rate, which is 0.032 t, right? So that's actually unknown there. It's going to be a little bit more work. Divide it like this. So you go 25,000 divided by 17,241.38. That's 1.4499 dot dot dot. And on this side, you're left with 1 plus 0.032 t. I will subtract 1 from both sides, leaves you with 0.4499 dot dot dot. And on this side, you're left with this. You divide both sides by 0.032. So time is 1 second here. Made a bit of a mistake here. Time is 14.06 years. That's how long it would take. And the rest, I will have to just scan it and post it. That's as far as I could get. There are more questions here. Page 14, questions. I think this is textbook. Anyways, good luck.